Hello students, welcome to Acadshala.
Today we are going to do numericals of the chapter Force and Laws of Motion of class 9, chapter 9.
But before starting today's session, it would be great if you like this video, share this video and subscribe to our channel Acadshala. This gives us a lot of motivation to keep creating these kind of videos for you all.
The numerical says, a bullet of 10 gram strikes a sandbag at a speed of 10 to the power 3 meter per second and gets embedded after traveling 5 centimeter. Calculate the resistive force exerted by the sand on the bullet. Second part, the time taken by the bullet to come to rest. Now students, whenever you read the numerical, try to make the diagram on your own or think about what the numerical is saying. Now they are talking about the sandbag. So I have shown the sandbag over here, and according to the demand in the numerical, it says a bullet which was of 10 grams strikes a sandbag. Okay. And that was the bullet speed was 10 to the power 3 meter per second. It struck the sandbag and then it got embedded. Embedded means it went inside the bag where the sand was. So it got embedded after traveling 5 centimeter. That means it went through the bag, but it traveled the distance of 5 centimeter also in the sandbag. Okay. After this, they are saying, calculate the resistive force exerted by the sand on the bullet. Now students, when the bullet was going, that means was getting embedded in the sandbag, the sand also must have exerted some force. That means the resistive force. Of course, it's very true. And we have to take out the resistive force exerted by the sand on the bullet. Okay. Now, according to the demand in the numerical, I have come to know what is given in the numerical. So let us write down what is given in the numerical, and if it is necessary, if it is a demand, we will also do the conversions as well, because this is the first step of the numerical to be done. Okay. Now they have given, of course it is there, 10 to the power 3 meter per second. That means it is the initial velocity of the bullet. That means when it started, 10 to the power 3 meter per second. But after getting embedded into the sandbag, it stopped also. So that means the final velocity was 0 meter per second also. This also I have understood through numerical only. Now, what is the mass of the bullet? That is 10 gram, which is given over here in the numerical. So, my mind says that it should be converted into kg. So, my first point in this numerical will be to convert gram into kg. So, what I have done? 10 upon 1000. After calculation, 0 gets cancelled, 110, and then do the calculation. I get the answer in the last as 0.01 kg. Now the second thing, that is, it also traveled the distance. Where? In the sandbag. How much? 5 centimeter. That is also, it is there in the numerical, they told us. Okay, so S is equal to 5 centimeter. Now again, I have to convert into meter. So what I will do, I will convert it, that is 5 upon 100. I will get the answer in the last 0.05 meter. So now all these 4 values I have in my hand. Now my numerical says, calculate the resistive force exerted by the sand on the bullet. Okay, now it strikes in my mind also about the formula for the force, that is F is equal to ma. To my surprise, oh my god, acceleration I don't have. No worries, I can take out the acceleration as well with the help of these values over here. Okay, now the best suited formula to take out the acceleration which strikes my mind is, that is 2as is equal to v square minus u square. Okay, after knowing the formula, it strikes my mind that I should quote the values in this formula to take out the acceleration. But please take care about the calculation as well. Okay, I put the value, that is 2 into A, I have to find out. S over here I have calculated, done the conversion over here. Directly I will put the value 0.05 is equal to v square. Of course, I have 0 meter per second. I put the value 0 square because the formula says v square minus u square, that is u value. Of course, I have 10 to power 3 meter per second. I've quoted the value directly over here, 10 to power 3 whole square. Why this whole square? Because the formula says u square. Okay. After doing this, I will now do the further calculation, simplify further. That is 2 into A into, now to remove the decimal, what I will do, 5 upon 100, that is 1 upon 100 is equal to 0 square is 0 minus 3 2s are 6, 10 to power 6. So I will do the calculation over here only. I will simplify further. 5 1s are 5, 5 2s are 10 and 0. And then 2 1s are 2 and 10 2s are 20. Okay, I have simplified here only. Okay, after this, the simplified value comes out to be A upon 10 is equal to minus 10 to power 6. And if we do the cross multiplication, it will come out the value, the final value of the acceleration. That is the final answer will be A is equal to minus 10 to power 7 meter per second square. Always keep it in mind, students. The units are very important. Keep on writing the units. Otherwise, your marks will be deducted. Okay. Now, after taking out the acceleration, now we have the formula, that is F is equal to ma. We can quote the value of acceleration in this formula like this, like F is equal to ma. So, m is the mass which we have the value already. We have calculated 0.01. We will quote the value over here, and acceleration value also we will quote it over here. We will solve it and we get as F is equal to minus 10 to power 5 Newton. Now what does this minus sign indicates? It's very, very important, children, to note. Negative sign indicates that the force is acting opposite to the motion. Now sometimes they ask also, what does this negative sign indicate? In one word answer also, like situation based questions can also come. So you should understand and you should know it also that this negative sign indicates that the force is acting opposite to the motion. Now children, we have done, that is force, and we have also calculated the acceleration, force. Now the time has come for the calculation of time. Okay, now we have the values already. That is, we have V value, we have U value, we have A value also. Now the best suited, the formula to quote these values, which I think is V is equal to U plus AT. Quote all the values over here. That is V0 is equal to U is 10 to power 3. So I've quoted the value over here, and A acceleration we have taken out already, minus 10 to power 7, and T we have to calculate. So we will take this expression this side. So it will become 10 to power 7 T is equal to 10 to power 3. And time we can calculate 10 to power 3 upon 10 to power 7 is equal to, simplify, that is 1 upon 10 to power 4. If we take 10 to power 4 up, I will get 10 to power minus 4 seconds. Why seconds? Because we have to calculate time. And time unit is always in seconds. So students, like this, keep on revising the numericals and keep on subscribing the channel to your own Acadshala. Link with your friends, nears and dears. If you really like it, please do subscribe and share with your friends too. With this positive note, I wind up the session. Thank you. Bye-bye. God bless.